Hello and welcome to this webinar. I have with me Rashbir today. And hello, Rashbir. Thank you to be
Hi,
with us
Nico.
today. Yeah,
How are you?
fine, fine. How
Great
are
to be
you?
here. I'm great.
Yeah,
Just back
Ra-
from vacations and super excited to see what we're going today.
yeah. Rashbir and us have been collaborating for a long time now. We wanted him to be here today in this webinar, where the main focus will be this new challenge we are giving to all of you, where we want you to build a virtual lab, and we are gonna walk through that. But we just finished a challenge, Rashbir, and
Yes.
we want to tell how it went. We
Okay.
had a winner. It was a challenge about uh, building an IoT coffee machine. It was a pretty cool challenge, and you are an expert in MQTT, so that was
Yeah,
also your area. Yeah,
I was working on the MQ routines in last months and years, so this challenge was very great. And luckily, one of my students won this challenge. So if you see the winner,
yeah,
Evis, he's one
it
of
is.
my
Yeah,
students who did MQTT course. So in this challenge, it was we have to automate this virtual coffee machine using MQTT as a communication protocol. And if we would like to show you a video of
yeah.
that
I'm
in
gonna
which,
show the. I'm
yeah,
gonna
yeah.
put the video. Yeah,
So
so
in
we
this
can.
video, the guy programmed this using Node-RED, and in Simumatik, it's possible to link your Node-RED via MQTT just using IP address and port. So if you see in this example, you have several nodes which he used to make some sequence, and then he hosted this on a server which you can access using mobile phone. So this you can see as a mobile phone, which has a dashboard, and this is interacting with virtual IoT coffee machine in Simumatik.
It's great. He
And
did. He did
yeah,
his mobile app and everything.
yeah, he did it by own, and that's why I think he deserved to be the winner. And you can see by clicking the buttons, the machine is simulating and showing how you can make a coffee with some notification on this digital screen. So in Simumatik, it's possible that you can just change the variables, and you can see simulations happening right now.
Yeah.
This
Yeah.
was very interesting.
We had several people participating. All projects were really interesting.
Yeah.
We had one that built this AI coffee machine that you
Yeah.
could have a conversation. That was nice
It was
project.
very-
Yeah, but I think it was very good project. We saw people approaching it in different ways. So pretty happy with the results. Coming back to the
And
presentation.
yeah, if you want to have a view of this video, you can just join on LinkedIn, and we have posted all the updates in our LinkedIn Simumatik page, and you can have a look.
Yeah, so if you haven't followed us yet, you can follow us both in YouTube and LinkedIn.
Yeah.
So we send Evis this Amazon gift card, and he also got the free subscription. We can also mention Yasser, that he got the second prize.
Yeah, and prize.
Very nice project as well. So we are expecting now in this new challenge to have mostly teachers or teachers and students participating, so they can give a try to Simumatik, try our platform, and build their own lab. Okay, so it's super easy to participate. We have prepared this QR code. If they scan it, you can just scan it. You will be you will come to our website, where you will find a submission form, so you can apply for the challenge.
Okay.
And then this webinar is the first step. We are going to be talking about what you can do, which options you have, and so on. But the idea is to start exploring Simumatik. Start playing, we are gonna check into our academy, get some inspiration maybe from this webinar or other stuff you can see already in the platform, and just keep building. And we will be there for helping. Yeah. So once you have a start with your project, we will have regular support. So all the people that is taking part in this challenge will have support from us. We have our engineers helping with the forum. We will arrange weekly tutorings, and there will be more webinars as well. So this is
Yeah,
just the first one.
great.
So what are we hoping you can build? Anything related to mechatronics, automation, we love that. And what we have seen with our customers is that building these mechatronic or automation labs, we help teachers to, so their students can have these virtual labs, they can work more efficiently, they can work in parallel, and they can actually find or explore new areas, or even more technology. So we are hoping that you can come up with ideas to build virtual labs so you can enhance your students' experience. And I mean, you
That's
have
perfect.
tried Simumatik. It's fun.
Yeah,
When you
it's
are
fun.
playing,
Yes. I have only worked with the pre-built library in
Mhm.
Simumatik. I haven't used my own, own equipment. So I'm excited to see in the today's demo how we can do that. That
Yeah.
will be interesting.
Yeah. So we can build systems with the components that are already published by us or
Okay.
other users, but
Mhm.
of course, anyone is able to build their own components and build their own system. So
Okay.
we are going to touch that as well. So
Mhm.
anything you can add, robots, PLCs, even if you want to mix IoT. I mean, PLCs and
Okay.
IoT are getting closer and closer.
Yeah, totally.
So we are seeing almost all PLC brands now introducing IoT clients in the PLCs.
Mhm.
So why not? I mean,
Okay.
and how to get inspiration. So we have this course in our academy. I'm gonna jump to the academy
Yeah,
pretty
I've tried
quickly.
one of this
Yeah.
course and I tried to simulate a conveyor, just
Yeah.
one part. It was really interesting.
Yeah, I mean, it's very powerful, the componentator. You
Yeah.
can build
It
whatever you
was it
want.
was actually very easy to
Yeah,
just simulate a conveyor box running on the conveyor.
but I mean, it takes some effort. So you need to
Yeah, it
learn the
takes some
tool,
time.
and you need to understand how it works, so you can actually start building.
Okay.
So this is the course I was mentioning. So just go to academy.simumatik.com.
Mhm.
If you have an account for our platform, you get free access to all these courses. And these are the courses that we once you get started to Simumatik, we recommend to take. Okay, just to get the big picture, what is needed to build something in Simumatik. Okay.
Okay. And one question, Miguel, how do they start? So they sign up and they get 30 days access, right?
Yeah, for this
Okay.
challenge, we are
Hmm.
gonna fix. So we are gonna create a challenge organization. So
Okay.
each team of teachers and students will be able to work together and actually
Okay.
see how you can collaborate with Simumatik
Oh, wow.
together to build this system. So we are gonna give access during the challenge
During
to
the
all
challenge.
the teams. So they
Okay.
will be seeing how the sharing features that we
Okay.
have
So
mentioned
they
in
have
other
full
webinars.
access to the platform,
Yeah,
complete access.
yeah,
Great.
they will have full access. They will
Okay.
build these labs, and we are gonna publish the results, and then we
Okay.
are gonna have a winner.
That's great.
So with that, it's just again get started with Simumatik, dig into the existing tutorials, the academy content,
Okay.
and then here is where we have the main path. Okay, what
Okay.
this is the learning path we call build your own virtual lab, and here we take
Okay.
you through different steps. Okay, I will
Okay.
say that this course is the most important, and
Okay.
before we go through uh, or play a little bit more in Simumatik, I
Okay.
want to show a little bit
Okay.
how you need to think
Hmm.
when you are going to build a system, and
Okay.
which kind of knowledge you can expect. Okay,
Okay.
this just to make people understand. Okay, I want to
Okay.
build my own virtual lab. What do I need
Okay.
to do that? Okay, so if you are not familiar with Simumatik, it's a platform where you can model in a 3D environment
Hmm.
different components and put them together, so you build a system like in the
Okay.
real world. Okay, you go to the shop, buy a stuff, connect them together, and then you create a system. In Simumatic, the
Okay.
concept is basically the same. We call it component-based modeling.
Yeah.
And you have the visual aspects, so you can bring all your nice 3D models, then you give them, you bring them to life, as we usually say, adding physics if you need, the behavior of the elements and so on, and then you connect them together. So this is like the overview. And as I was saying, the concept is like in the reality. So if you're going to build a pneumatic system, you need a compressor, a valve, and a cylinder. In Simumatic is the same. So you digitize each component separately, and then you put them in the same system. You connect it like in the reality, and then if you do the connections properly, the system works. If you miss something, the system won't behave as expected. That's the idea. So without going into many details, because we really want people to go through this, I think this slide is quite interesting. What do you need if you want to build, for example, the example system that we are seeing in the screen? If we want it to look as close as possible to the reality, of course, we need the 3D CAD models. Okay. And you can have them in several formats. And we have courses in the academy that show how you can bring them to Simumatic. Just as a spoiler, I want to say that we are working very hard now to include all the importing and simplifying tools inside Simumatic. That's going to be a huge step, because we know it's not easy to bring CADs directly to technology like emulation, because CAD is usually very detailed, and we need to simplify.
That's true.
Yeah, so we are including all that in Simumatic. So in the coming months, be very close to our news, because follow us, because it's gonna we are preparing an update where we will have all this integrated in Simumatic. So just you will be able to drag and drop a 3D model from a standard CAD format and perform some operations like simplification and optimization. So the model will be ready for this kind of use. Yeah. And of course, you have a picture or the 3D models of your system, but you need to know which are what we call the ingredients, which are all the components you have in your system. And this is what we usually say. In the reality as well, if you are going to build something, you need to make a part list. You need to decide, I'm going to use this component, this sensor, or whatever. You need to start with that, and then you do the schematics or whatever, so you know you design how you are going to connect everything. In Simumatic, it's the same. You need to decide.
And the good thing is you can take the sensors and actuators directly from the library.
Yes. So in some cases, you will find the components already in the library, or maybe not exactly the same component, but similar components. And then we show how you can clone them, modify a little bit, and so on. So we probably will have more webinars about that, but we already have all these in our academy. So you make your part list, what you need to build your system, and you take it from there. So there you start exploring what Simumatic already has in the libraries, what others have published, and you try to identify which components are already there. And the ones that are not there, those you can build. And that's the beauty with Simumatic as well. We have something called the componentator. We are going to see it later. But there you can build the components or digitize the components that are not yet digitized. So as we are going to see now, we build this virtual lab completely from scratch, all the components, but if we can do it, you can do it as well. So we use the same tools that we offer to all our customers. So again, 3Ds help. Partly super important. You need to know what you are going to use in your system, and then with the schematics, you decide, you define how you are going to connect everything. If you are using a PLC, good to design or have the IO list and these kind of things. So now if you find all the components you need to build a system, you actually don't need very advanced knowledge to use Simumatic. You mentioned you already built some stuff with components from the library. I mean, you need to get the basics, drag and dropping components, connecting, you are done.
Yeah.
And that's a little bit the idea with Simumatik. If you can build it in reality, if you understand schematics, if you understand the components, we don't request or require more knowledge to the users
Okay.
to build it in Simumatik. Yeah.
Okay.
But if you need to build or digitize new component, that's another thing, and
Yeah.
that's something that everyone needs to understand, that you need to learn
Yeah,
modeling.
because a lot of physics involved and constraints
Yes.
involved. So yeah,
Yeah.
that's another
Behavior and
okay.
so on. So that's
Behavior.
another thing. But
Hmm.
if you find components, anyone knowing how to build the real thing should be
Yeah.
able to build it in Simumatik. If you need to model, you will need
Hmm.
to go some courses in academy,
Okay.
more extra courses to learn modeling. Okay.
Okay.
So that, I think, I
So,
hope it give a
hmm,
picture.
hmm.
Okay.
So what we are going to see today
Yeah.
in your
So
live demo.
we are actually gonna show this system
Hmm.
that we had in that tutorial. So I'm gonna
Okay.
jump to Simumatik. Now you see my screen.
Yeah.
This is what we get once you log in.
Okay.
And if you are not member of an organization because
Hmm.
your school or your company doesn't have a subscription, you will just see your own
Personal
card.
account.
Yeah.
Okay.
And as you mentioned, everyone signing up gets a
Hmm.
free month. So
3 months.
this test John Doe account, this is just a dummy account we use for this
Hmm.
kind of presentations. This already gone past the free month, so that's why
Okay.
it says upgrade plan, and then
Okay.
you can buy a individual subscription for no
Okay.
commercial purpose.
Okay.
But let's say you participate in this challenge, then you will see we will invite you to
Okay.
to an organization where you can play and build.
So they will see an organization already when
Yeah.
they sign up. Okay.
Yeah, we will call it the challenge organization
Challenge
or
organization.
something like
Okay.
that. They will get access, and from
Great.
there they will be able
Okay.
to create and will get full access. Okay.
Okay.
And then as you know, Simumatik offers both working
Yes.
online and cloud. Right
Hmm.
now, I'm gonna jump into a local workspace just to show
Okay.
this system. Okay, so the system that we have in this learning path
Okay.
is this.
And this is public. They can also have
Yeah,
a
I
look at
mean,
this. Okay.
you see up there. I just went to the public
Yeah,
system,
this was a
search
public
for
system.
the
Okay.
tutorial.
So this
Yeah.
is there, and they can directly view and access. Great.
Yeah, and I wanted to use this system for this webinar because actually what we always suggest is, if you want to learn, start looking to things that are already done.
Yeah, true.
You get inspiration from there, and
Hmm.
the beauty is with the cloud-based platform is that anything you like, you can clone and make your own.
Perfect. Okay.
You can make your own copy. So if you
Mhm.
like, oh, I like this this
Components
conveyor
or-
here, yeah, I like it. I want to change the color or whatever. Then you
Okay.
can always clone it and
Okay.
make some modifications, and you will have it in your own private library. Okay.
Okay.
We also provide opportunity, and the ones participating in the challenge will be able to publish their own components at the end if they have created their
Okay.
own components.
Mhm,
So
they can
those will add to the platform and the community. So there will be
Okay.
more stuff shared
And
with
they
them.
can also access the components published by others, so they can
Yeah.
share the components. Great.
Yeah. So yeah, this is what we see when we load our
Mhm.
system.
Okay.
It's not a very big system. You see, this is just a table, one
Mhm.
1.5 meters by one
Okay.
or something like that. So it's not a huge lab, but it's the typical lab you can see in a school lab.
Okay.
I mean,
Yeah, totally.
yeah. So it looks pretty much as the real thing. And in Simumatik, as I said, everything is a component, and you basically group components in what we call assemblies.
Assemblies,
Okay,
yeah.
so all these here, the first level in this tree are assemblies, and then we have the
Okay.
product entries and exits.
Mhm.
We will go through that later.
Mhm.
And then inside these assemblies, we have different components. Okay,
Got it.
yeah. So we can hide or
Hide the assemblies. Okay.
show different assemblies.
Okay.
And this is the 3D view where we can select different parts. Some
Mhm.
parts we will see that they have some parameters. Let's see if we can come closer to this button. Some
Okay.
components, they have parameters we can change, like this button. It's kind of generic button where we have used it twice, and in this
Mm-hmm.
case we change the color to
Okay.
white, and
Okay.
this one is gray, but it's the same component, it's just two different instances.
Different colors. Okay.
Yeah. And the components have also, as I mentioned, they have the
Oh, great.
3D aspect, and they
Okay.
have the ports. So this shows how they are connected. Okay.
Okay.
But as you know, since some months ago, we have
Yes.
switched between 3D and 2D. Okay, we are still
Perfect.
working in this feature. It's super powerful,
This is the
but
best.
it's still work on process. Progress, we could say, is kind of beta.
Okay.
But the idea is also to show the users that actually what they
Mm-hmm.
are doing is what we are telling.
Yeah.
What we were telling before, they
True.
drag and drop components, and they
Mm-hmm.
connect them like reality. So actually, they are reproducing the schematics in Simumatik. Yeah,
Okay.
and that's why they can do the connections. Here we see all the buttons, and we can see
Okay.
the sensors and so on. These are the digital input
Mm-hmm.
cards.
This
So
one is about.
we can see the components connected. We can jump between
Oh, wow.
screens and so on.
Great. I have a question.
Yep.
So if you connect the schematic here, it will automatically connect in 3D, right?
Yes.
It
Yeah.
works both ways.
So
Okay.
it's both ways, and again, it's still a work in progress. But the idea is that
Okay.
you can do connections here. If you
Okay.
remove the connection here, it will
remove it.
disappear.
Okay.
Yeah,
Great.
and then you can do it here. So
That's very nice.
somehow, when you have done the connections using the schematics, which is not
Okay.
mandatory, you
Mhm.
are kind of documenting as well your system, so
That's
you can
perfect.
use it. Yeah, I mean, after that you can click here, and you
Print.
can it will print all the pages in a PDF.
Oh, wow.
So you will be able to take that and add
Okay.
it, offer it to your students. We
Okay.
see it here, and they look quite like a real schematic.
That's very
So,
nice. Yeah. Okay.
So anything, any comment around that, the 2D schematics or new features and whatever, you can ask in the forum, because
Okay.
this is a very powerful. We believe it's a very powerful feature in Simumatik,
Mhm.
the 2D view, and it's good to always have feedback from the users. So
Okay.
anything you see, don't hesitate to contact us, tell us what you
Okay.
think, write comments in the YouTube channels. We have a webinar about actually about this feature from
Okay.
last Christmas, I think, or this spring.
Okay.
So yeah, now is everything connected. That's
Mhm.
why we could see all these
Okay.
connections done. And I'm gonna click play now.
Your
just to
base is missing. Maybe you can unhide the base, the table, because now it looks like floating.
Yeah, that's true.
If you like, you can just
Yeah.
Perfect.
So now I click play. Now
Mhm.
now we can play with this system.
Okay.
Even if there is a electrical cabinet here, we
Oh,
have
wow.
we have a PLC,
Oh, this looks very nice. Okay.
but we haven't connected the PLC
Okay.
right now. But
Mhm.
all these components that have been digitized are actually
Mhm.
interactive. So I can
Oh,
click
so
it.
this is manually controlled with your
Yeah,
button. Okay.
we can click in some of the
Mhm.
components, and we can make
Okay.
them behave.
Simulate. Okay.
Yeah, simulate.
Great.
So what's going on in this lab? I'm gonna
Okay.
drop a button.
So
a
this
button, a
blue
piece. Yeah.
thingy. Okay, these blue circles are the drop item.
Yep.
Okay.
Yeah. These are the ones that we call product
Okay.
entries.
Product
Yeah.
entries. Got it.
And we have one for each type of product. So
Okay.
first we are gonna drop metal peg.
Okay. This is the
And now
base.
I can do
so you
the
click and
conveyor.
run the conveyor. Okay.
Yeah.
And there are two sensors on the top. What are they sensing?
Yeah, they are sensing. I think one is just photoelectric and the other is inductive. So both see the peg.
Okay.
And now you saw the ramp. The
It slides
peg
down. It has some
slides
physics.
down.
So
Yeah.
Okay.
Now it passes. So it's
Okay.
centered here with this with the physics as well.
Mhm.
And now it will go through this pair of sensors. But you see here, this one just detects.
Yeah.
Just detects if there is something at this level.
Okay.
Let me see here.
Yeah.
So it's not seeing anything, and that's why we can use it
Okay.
to detect if we have a assembled part. In
Okay.
this case, we just throw one of the pieces. There's
Okay.
going to be an assembly process. We are going to see it now,
Okay.
but I can show you that we can move it all the way forward, and then we
Okay.
have two options. We can discard here with a
Okay. With the
pneumatic
pusher.
cylinder, yeah, with a
Okay.
pusher, and what we see already now is the physics, okay,
Yes.
and we see the product falling down and
Mm-hmm.
all this physics, so it behaves nicely as we were seeing. It's gliding
Yeah.
through the ramp. It's centered here.
Runs perfectly.
Yeah, if we go back to the academy page, there
Mm-hmm.
we had a special course. Let me go back a little bit more.
So there's a specific course for
Yeah,
adding the products.
product.
Okay.
And here we go through the physics parts and so
Okay. So
on. So
there, students can learn how to add physics to components.
yes,
Okay.
yes. Let's go to the let's have the second piece, which is
Mm-hmm.
the plastic ring. And
Okay.
again, in this case, the idea is that when the plastic ring comes
Okay.
here, it's not detected by this sensor, just by
Okay.
this one, and then we can push it, and it's gonna
Okay.
fall
A good
down
ring.
here. Here we can build a buffer of rings.
Buffer of rings. Okay.
Yeah, and then when we click in this,
Okay.
we just
will release
let
the part.
one pass. Yeah,
Mm-hmm.
and now we can.
Bring the lower part.
Yeah, now we
Okay.
can. Now we can bring the second part.
So students can automate this process using a PLC logic.
Yeah,
With the sensor
yeah.
signals and conveyors. Great.
And this is also up to
Oh, nice.
the
Can you zoom it a
yeah,
little bit? How this is
yeah,
interacting? It would be really nice to
yeah.
see.
Yeah, you
Okay.
see there, it's
Wow.
interacting, and it's kind of nice mechanical assembly. So
Yeah,
this
it's
is
very
moving.
nice.
Yeah, so this is moving now both together. Both sensors were active, and so on. So the second thing we saw now is these actuators here. Okay, so we have this cylinder we can touch here. We have this rotatory cylinder as well. This is also
Explained in this course.
explained in this, okay, and in this one we dig into how you build a conveyor. We were mentioning before.
Yeah, I just tried one.
You try that. How to make how to build a cylinder, pneumatic cylinder, linear, rotatory, buttons, these kind of components. We have this special course for that. Okay.
Perfect.
Maybe you don't want to use exactly the same component, but
we can
as I
optimize
mentioned,
it or customize.
yeah, you can customize it, and I think now we can show that. What I'm going to show now is that these pink cones. We mentioned there was something else. We mentioned the product entries. Now we have product exits. Okay.
Exit. Okay.
Yeah, and these are to grab products and delete them automatically. Okay. We can decide if we want to add a delay or not to the removal. But at this point, the delay is 0. So as soon as the product passes, it's going to read it.
Okay.
And it's something important to understand, because as many products you have in a system, it's more physics going on. The computer will require more power to run everything. So it's always recommended to have just the necessary parts in the system running at the same time. So don't be shy to add product exits instead of throwing products to the floor, for example, because the system will be slower and slower as it goes otherwise. And this way, when they come to the end, they don't really make sense anymore, so you can remove them.
So would you like to show some more information about the inside of the component? For example, this conveyor, what are the variables? Why does it move when you click? What's happening?
Yeah. So that's what I'm gonna do. So each time you select a component here or in the 3D environment, you can open the menu here, and you can go. You can select two things: component info, and this is just a quick info. Just to see, what is this about? It's just the component name and what we call the description.
All right.
But if you really want to see what is inside, how this component has been digitized, you can click Open Component Page. And this is what we mentioned before is what we call the component editor. Okay.
Okay.
Here we can see the description that we were seeing before in the component information, the name, some metadata.
Okay.
And here is when it starts to become interesting. Okay. So
Okay.
here we have some assets,
Mm-hmm.
and the assets are files that get attached to that component. And
Okay.
those assets can be everything from a CAD model, just to
Mm-hmm.
add the 3D representation to the model, a
Okay.
script for the behavior. It could be anything, actually.
Okay.
It could be a data sheet. If this is
Okay.
a commercial part, you could upload as well a data sheet and have it as a part of the documentation of this component.
Okay.
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 So some components, of course, are necessary to digitize the component, or some assets, sorry, but some other assets can be just documentation and other stuff.
Okay. So, for example, if some student wants to upload their own component, so he needs a CAD file, which I see the first one, like say belt model.
Yes.
This is
Yeah.
a CAD file.
Yeah.
And the
So here
second
we
is
have this is the
behavior
behavior
script, a Python
script.
script. I can
Yeah.
see it. So, okay.
And actually here we have two CAD models. This one
CAD
is
model.
the
Belt model. Okay,
yeah,
because it's a belt and sheet metal. Okay.
yeah. So it's two because it's done in two parts.
Two
Okay.
parts. Okay.
Right now, because this is a public component, I can see everything because this component is not blocked. There is an option if you want to hide or keep your intellectual property on a component. You can block it before publishing, so no one can actually see what's inside or how is it done.
Okay.
But all components we publish from Simumatik are always totally open, so you can see everything, and you can do the clone thing.
Okay.
So if I would like this, I could just click here, make a clone, and then I can start modifying.
Okay, you can use it. Okay.
But right now I cannot modify it because this is the public version. So we are just looking
all right
what is here.
Okay.
So in the second page, we see
editor,
the actual component editor. Yeah.
Mm-hmm.
And here you can do everything we have been mentioning. We can work through that in a second.
Okay.
But something quite interesting, and I think is part of our basis in Simumatik, is that we are really open on how things work. I mean, we don't want to hide anything. So this third tab actually is showing what you are doing and how this component has been digitized. Actually, using just an XML file. This is completely transparent. We don't hide anything. It's like a
blueprint of your component. It has everything inside.
Yeah, and this is everything. Everything you do in the component editor in a more visual way. We don't hide it. It becomes a file. So you understand. It's a file which you can actually edit manually. It requires more expert knowledge, but we actually do it sometimes to do things maybe quicker or do some tricks. But what I wanted to say is that the platform is super open. A component is just this file with the assets we are seeing here.
Okay.
That's the component. So you have full control and full view of what's happening behind the scenes.
So what you do in editor is automatically generated in XML, right?
Yes. Yeah.
Perfect. Okay.
So the editor allows you to add different puzzle pieces, we could call them. So you can elaborate your component depending what you want to do. You have visual puzzle pieces where you can add a geometry, a mesh, and so on. All these, when you don't know what a piece is, you can click here, the information button. It will tell you, okay, what exactly this is, or what you can do here, and so on. Okay. And we always recommend to take a look to the
user manual. Okay.
Yeah, because here, what we call the data model, we have all these parts. You see the puzzle pieces. You can come here and you can read about. So, for example, visual, what it is, and we have. If you want to know about geometries, here we have different kind of geometries, and we were seeing a mesh. So maybe mesh geometry. So you can go inside. And you can take a look more in detail what is the part and so on. It's kind of help. Yeah. And this is actually where you connect this puzzle piece to the asset. Exactly. Great. So you see here You can see
Okay.
the assets. It just allows you to select the ones that are compatible. Okay,
Okay.
because we mentioned we had
Mhm.
Python script and two
Yeah. Two
3D
CAD
models.
models. Yeah.
Yeah, so it allows you to one, or if you want, you can add a new asset if it's your
Okay.
own component.
So you can
Uh,
add 2, 3 components in the model, and
yeah.
these will be okay. Great.
And this is the other part where we had also an asset. It's the
Behavior.
behavior.
Okay.
This is where you add the logic to your component, and again, here
Okay.
it's linked to another
Logic.
asset. Yeah.
So this logic is the script which is uploaded in the asset.
Yes. So
Okay.
yeah, it's a lot of stuff here, but again, it's totally open.
Okay.
So you may not start with this component. We have other more simple
Okay.
components. We have
Okay.
tutorial how to start with a very simple box, for example. You can take it from there, but again, it's I wanted to show this
Okay.
example because everything is completely
Everything is open.
transparent. If
And
you
one
want,
question, you can also edit the script here, right, on this
yeah,
screen.
yeah,
Okay, so you don't need to upload. You can just type
no,
here and
yeah,
it
and
will be
save,
saved.
yeah,
Okay,
yeah. So you can do the
great.
changes here, yeah.
Okay,
We cannot save now because we don't own this component, but in case we
okay.
had done a clone, then it's just
So
so simple. You click here and you say, okay, you're
upload it,
gonna
and then you
you're
can
gonna
change
clone it.
it.
I
Okay,
can call it my elevator, for example, and then
okay,
I can after I do that, we can just do it just to show.
okay.
After you do that, then
Now it's
now we
loaded.
can start doing stuff. Yeah, and if I
Okay.
modify something, I modify the description or whatever. Now I can start saving.
Mm-hmm.
So basically, I did a copy of that element. I can start changing color or whatever and take it from
So
there.
now it's your own customize.
Yeah,
And so student needs to have a little bit information about the Python, how to write a script. So Python is the language they need to know a little
yeah.
bit.
Python is
Okay.
the language, and we have actually another learning path which is called
Okay. Python.
Python. Yeah,
Okay.
and you can use we use Python for building the behavior of the component
Behavior.
because
Okay.
we like the language and it's
It's easy to
so
learn
easy
and
to
stuff.
use and so
Yeah.
on. But you can actually control systems
Also.
done in
Okay.
Simumatik using Python. So
Okay.
we are starting to have customers that use Simumatik, not just to automation and mechatronics, also
Okay.
to teach and make learning programming more fun because
Great.
it's not the same running just a
Mm-hmm.
console script or
Mm-hmm.
running a
Yeah.
virtual system. For example, like we did with the IoT. I mean,
Yeah. Like MQTT and Node-RED.
NQTT and all that,
Perfect.
you do things maybe more fun.
Okay. Perfect.
So yeah, that was the componentator. I don't want to go very into
Mm-hmm.
details with all the different parts, but again, we have the academy. You can always take a look to an existing component. For example, now, okay, let's see how this rotational cylinder works, and you
Okay.
jump here, and you can see in this case it's a more
Mm-hmm.
simple component. You see
Okay.
here all the different parts.
Okay.
And between all these parts, we have everything from the symbol,
Mm-hmm.
we have the
This
3D, we
okay.
have mechatronics, or in this
Mm-hmm.
case, kinematics. We have the joint and the link,
Joint.
so we can actually make this rotational movement.
Okay.
We have the behavior script,
Behavior. Okay.
which you see
Perfect.
here, it doesn't need to be super advanced. In this
Yeah.
case, it's pretty simple. I mean, it's just a few rows of code just to make this
I
component
see.
bring to life.
Those if else. Okay.
And then we have the electric input ports that are, in this case, I think I say it was a pneumatic cylinder, but it's an electric rotational.
Yeah. Based on the voltage, it will
Yeah.
rotate. So
So
you
when the
said
voltage, yeah,
wait, you mentioned the best way to build your lab is open this lab and see how this has been done.
yeah,
Check out this biotronics system and then build your own. So this is the first step. Do the
yeah,
course and learn what is happening here.
and you can go by focusing. Let's take this conveyor
Mhm.
belt, and you can hide
Oh,
almost
great.
everything,
That's
and
very
you
nice.
can start. Okay, what's let's take this one.
Okay.
You see this now we are talking about or seeing just these four components.
Yeah.
We have this DC motor,
Mm-hmm.
which is a very simple motor just with
Yeah.
24 volts, and then it has
Oh,
an rotational axis,
Yeah.
What's happening here? The rotational axis is connected to the elevating conveyor motor axis. So this is
Okay.
the second component, which just has
Okay.
it has
One
just
input.
an input port.
So they are
So,
interacting with each other in
yeah,
some.
they
Okay.
are interacting. And what else do we have? We have this
Feed.
ramp
Mhm.
and this
Peg deflector.
peg deflector. It's
Okay.
this one, this
Just the
part
physics
here.
components.
Yeah. And
Okay.
when we come to those, this is actually the next tutorial. Let me go back to this one. This one, static
Okay.
elements. So there was a lot of magic happening here with the
Mhm.
ramps, the automatic
Mhm.
assembly, and so
Okay.
on. There is a little physics playing there
Mhm.
behind the scenes, and we have a course just to
So we have
illustrate.
a course on physics as well.
Yeah,
Okay.
so we
That's
have a
very
course
important.
for those are the kind of very static components. They just
Okay.
are used to guide or make components collide or fall or
Okay.
whatever. If we jump inside, we will see that compared to the previous components we were seeing with
Yeah.
a lot of puzzle pieces,
Yeah.
these are super simple. In these ones, we just usually have these three
Collisions.
elements. We have the visual aspect,
Yeah.
we have the collision, and this is, I don't want to go very deep, but
Yeah.
this is a way we have to differentiate between what you see and what the physics engine can see. Why?
Okay.
Because you may want to have something that looks pretty nice with this
Mhm.
screw and so on,
Okay.
but you don't want to overload the
Yeah.
physics engine with a
Okay.
lot of unnecessary
Yeah.
details. So actually, what we can see, let me do this visible. Oh, sorry.
Okay.
So maybe we can see the physics is
Oh,
more
this is the
simple.
physics.
Yeah.
Oh, okay.
So you see, for the physics in this ramp, we just have the sides just for
Okay.
guiding and
Mhm.
just a little piece here to make this turn.
Okay.
Okay. Compared to the visual
The whole
aspect,
component.
yeah,
Okay.
which is much more detailed and has other stuff that we don't really
Okay.
need. And the
Okay.
thing is that you can actually do some little tricks. So you see here that the guys saw that adding this
Mhm.
physics here a bit
Mhm.
more angled than the real
Okay.
thing, it
Okay.
actually makes the movement smoother. Okay.
Smoother. Okay. So let me ask you, how much time does it take to add physics? Let's say this component, the whole component which we see here, how much time generally takes to add physics, collision, surface?
I mean, if you take one of my guys here, one of the guys in the team, this can be done in 1 hour or a few hours max if you really need to be playing around,
Okay.
because sometimes it could be a kind of iterative process where you are trying
Okay.
to trim the physics and so on. And in this case, this is kind of challenging
Mhm.
part. Okay, there are
Okay.
other parts like the other this part here is much
Okay.
simpler when it comes
Okay.
to the physics. Maybe this is something you can fix in just a few minutes. Okay,
Okay.
the physics is in this case is super simple. It's just a
Just
wall here
okay. Yeah.
compared
Okay.
to the is this transparent
All
part.
right.
So,
That's all.
so in this case, this component could take just few minutes, just
Okay.
importing the 3D
Mhm.
just from the CAD tool, simplify, add the collisions where you think is necessary, and in this case, it's just a very simple collision. Okay,
Okay.
and that's all. Then you select the surface. That this is also something else you can define if you want
Okay.
more
Bouncy.
or less friction,
Okay.
bounciness, and this kind of stuff. So it can take for just few minutes to
Okay.
several hours, depending how challenging this
Mhm.
component is.
Okay. So do you recommend any software for people to build their 3D components?
Yeah, we use a lot Blender
Blender.
because
Okay.
it's open, it's free, and
It's free
it's
to
very
use.
open. You can import. I mean, Blender is used in gaming industry. They
Yeah.
are
Yeah.
very used to optimize 3D models,
Okay.
and this is something that industry needs to understand if they need to, if you want to use real CAD,
Mhm.
3D CAD out from different standard formats into
Okay.
these kind of models, because you need to do
Simplify
simplification
the
and so on.
models.
Yeah.
Yeah. Less triangles and I
And
imagine.
And there is a very nice course in the academy
Oh,
that
we have a course as well. Okay.
we could mention it. If we go here to the component editor
Okay.
courses, there is a course actually about generating
Oh,
efficient 3D
perfect.
estimate. And
Okay.
in this course, we give some tricks how you can use Blender.
Oh,
Again, it's
perfect.
free to use.
Hmm.
You export from your CAD format to uh, a format that is more geometry based format, like
Okay.
or triangle based format. Sorry,
Yeah.
like OBJ, GLTF that we actually
Okay.
use. GLB we actually use in Simumatik, and then
Okay.
you can play with it in Blender,
Hmm.
optimize it following our tricks,
Okay.
and then finally you come to Simumatik and you import it as an asset,
Okay.
and then you can start playing with it.
Okay. Perfect.
So yeah, 3D models usually through Blender or directly if they are enough simple enough, you can bring them
Yeah.
directly. If you can export them to GLB format, more and
Mhm.
more CAD tools can export directly to GLB. So in soon uh, will be available in almost all CAD formats.
Okay.
Anyway, as I mentioned in the beginning, we will be providing this important feature built
In
in
the future.
Simumatik very
Okay.
soon. So that's not going to be a problem. But yeah, you start adding the 3D, then we saw
Okay.
that you can add the physics, kinematics, different things depending what the component does, if it has movements or not, like these solenoids and so on,
Yeah.
solenoid cylinders and so on. And then the behavior using
Hmm.
these Python script ports and so on. And then you connect everything
Okay.
as we were
So
having.
just importing the CAD files, rest everything we can do in Simumatic.
Yep. Yeah.
Great.
And it's super important to learn as well how you want to organize your system so it's easy to handle. Then you saw as well that I was able to hide different parts, but when you group things into assemblies, it's not
Mhm.
just making them visible or invisible
Okay.
together. It's also about uh, positioning them.
Positioning them. Correct.
So if I want to
Because
position
physics is
all these
involved, so
groups
we have to.
together,
Yeah.
yeah.
Okay. Okay.
So now I can position just this assembly
Hmm.
or each of the parts separately.
Individual
So
parts.
yeah,
Okay.
if I do like that, then now I'm messing around
Yeah.
because
Exactly.
probably now this is not gonna work as expected anymore. But I can move the entire assembly. So you
Okay.
position things first within this assembly, within this group, you
Okay.
position them relatively to each other, and you can do the positioning or rotation. So
Rotation.
I can rotate the entire assembly, or I can take just one of the pieces and
Okay.
rotate it.
Okay.
Uh, and then you put them together, do the connections, and you're up
Okay.
and running. Yeah.
And one question, how do they save their progress, or is it automatically saved? What are they doing here?
You do click save button.
Click save here from
Yeah.
here. Okay.
Because this is a public system, I
Okay.
cannot save. But
Okay.
again, here is a trick. We could clone the entire
Clone the
system
whole
as well.
system. Oh, okay.
So
So this
now
is
I
the
could,
tip. For example, if they want to learn this, they can first clone the whole system and then they can make changes to see how it's working.
yeah,
Okay, that's a good tip.
you can actually build on top of this system and a
Okay.
robot, or uh,
Okay.
that's the beauty of having all this published content available for anyone.
Okay.
You can find inspiration in one with one system or one component, and then take it from there and build your own system.
Got
Uh,
it.
which we there is no limits in this
No
challenge
limit.
as well. Uh, you can build whatever you want. Of course,
And mhm,
it's great if you can build a virtual model of the lab you have in your school
yeah,
if you are a teacher, because then you can use it as most of our customers they do most of the practice against the virtual lab
yeah,
with the same PLC program. You can go to our YouTube channel. You can see how we program with Siemens, Allen Bradley, different tools, but you do the same programming against the virtual model, and then you could demonstrate that with the real lab,
okay,
because the same code or the same program can be used there. If the virtual lab behaves like the real one, you have this digital twin thing.
And the best thing is they can also connect their controller, the real controller, to the virtual to see how the code
Yeah,
is working, and they
yeah,
can fine tune the system.
and
Great.
it's both PLCs or robot controllers. So
Okay.
actually, other stuff as we saw with MQTT, Python. I mean, there is no limit what we can connect to Simumatik. So
Okay.
if there is, if for this challenge there is a team that wants to connect to a third-party software or hardware, and you don't find anything in
Okay.
our tutorials or documentation, just contact
Okay.
us,
Okay.
because sometimes just building the bridge or the what we call the drivers in our
Hmm.
gateway. The gateway is the tool that connects the models to third-party software or
Yeah.
hardware. It may take maybe one or a few days
Okay.
in the best case. So some of the
Perfect.
times it's very quick when we need to reverse engineer
That's
something because
perfect.
the
Hmm.
protocol maybe is not open or whatever. It may take some more time,
Okay.
but don't be afraid to ask and say, okay, I have this PLC brand. I don't see anything
Okay.
in your tutorial. Can we still connect? Uh, and Rajbir, that OPC UA is
Yeah.
opening a lot of doors. I mean,
True.
most of the PLC and robot manufacturers are integrated OPC UA.
Yeah.
So, and we can do OPC UA. So
So.
basically, you can connect
Mhm.
to anything
So
compatible
this would
with
be the
OPC.
best recommendation that we can use
Yeah,
OPC way because many hardware and software has OPC way communication.
yeah, and it's a time
Right.
question. I mean, in the coming, all the last generation CPUs in the
Yeah.
market are almost coming with the OPC
Yeah.
UA.
That's
So
true.
yeah,
Great. I mean, I think we have covered a lot of information about how to start the system. So if any
yeah,
student has any needs some help, we are going to have more webinars in the future.
yeah.
Okay.
And we are gonna communicate with all the participants. So each time we arrange these tutorings or new webinars,
Mhm.
probably we will have more open webinars, but the
Okay.
tutorings will be just for the participants. So we will
Just for
we will
participants.
keep in touch with you,
Okay.
and we will be the forum is open as well 24/7, so you can ask questions there, and we will be very
Okay.
willing to help.
And what about the price?
Yeah,
What
so
are we giving?
let's go back to the slides, and we were mentioning the help, so we
Okay.
covered that already. So the
Mhm.
price, yeah, we really want to give a free subscription for
Okay.
the team or the school or whatever, the teacher that is publishing the best
Okay.
the best virtual lab.
Mhm.
We will show the criteria during
Okay.
the course, but I mean, we really want to see virtual labs that enhance your courses. I mean,
Okay.
that's at the end what we believe that you can do with Simumatik. We want to
Okay.
bring you that value to your courses. We want to make teachers' life easier. We want to allow the students to have even more fun when they learn mechatronics,
That's
automation.
perfect.
We want to allow them this flexibility to bring with them these virtual labs home, have much many hours to play with the labs and learn even more than they do now. So we
Mhm.
want to see that.
Okay.
So that lab that shows that is properly connected or pedagogically connected to course, and we see
Okay.
that connection, we see that the usefulness for the students and so
Okay.
on, that
Got it.
that's the ultimate goal, and that's what we want to uh, uh, we want to see in this challenge.
Okay.
So we are giving that really nice prize.
That's perfect. I think I wish I would have this Simumatik when I was doing mechatronics because we didn't have it. So I would say it's a great opportunity for schools and students to talk to each other, make a team, talk to the teachers and the
Yeah,
one who are watching and promote this challenge and do
exactly.
something great.
Yeah.
No,
And
perfect.
even if we have a deadline for the middle of July, anyone can participate. We will keep the challenge open,
Okay.
almost the entire process. I mean,
Okay. Okay.
it's something. It will require at least a week
Mhm.
to do a lab, but we will keep it open so
Okay.
anyone can participate. We know different countries have different start and end of the periods, teaching periods, and so on.
Okay.
Teachers can be more busy now, or maybe less and less busy in a few weeks or a month. So we want to keep it a bit open. So
Okay.
as you were mentioning, Rashbir, if you are just a student watching this webinar, contact with your teacher,
Yeah.
put together a team, and submit so you can participate here.
And if they have any questions, where should they contact? Via LinkedIn is better, or via some email address?
Yeah, they can use our contact at simumatik.com. We have a contact form in the website, so that is also best place to go. So go to our website, use the contact form, and ask us any question. And yeah, I think we cover almost all of it.
So, yes, for sure. Otherwise, for any other information, you can also comment on this video on the YouTube. We can also reach you via this comment section as well.
Yeah, so what do you think?
I think I'm expecting some great submissions. I hope people are encouraged and inspired after watching this webinar. Otherwise, just go to the Academy website and check out the courses. I have done a few courses as well, and it's great. I think I love this Python course, how you can simulate this environment with Python. And now I learned a little bit how you can even build your system and add animation or simulation by Python. So it's going to be a great platform, since Python is being used a lot, and now they can use it to simulate and build their own system, build their own ideas. Nothing can be better than that.
Yeah, I mean, this is open for creativity. So, I mean, there is no limit. You don't need to build just something that you have in your lab, even if you have ideas. And we want to bring technology to even organizations that cannot afford technology. That's also something that we believe.
That's perfect.
Industrial robots, industrial equipment is expensive. If we want to make education as well sustainable, we need to start using more these kind of tools, because it makes easier access to technology.
I also think in some countries where the students cannot or teachers cannot build a whole mechatronic lab physically, they can just buy a controller and control the virtual lab, adding physics, so it's more real. Very interesting.
So we hope to see people taking part from different countries, and let's see how it goes.
And for next webinar, we have it on LinkedIn, so I would say people can join LinkedIn account and they can see the more updates.
Yeah, follow us in social channels, Facebook, Twitter, LinkedIn, Instagram, and so on. So we will be there updating.
Great.
Okay,
thank you for your time, Michael.
Thank you, Rashbir. It was a pleasure with having this webinar with you.
I learned so much in this 1 hour.
Okay, have a nice day, everyone.
You too. Have a nice time.
Bye-bye.
Bye.